Welcome to Schrodinger's Clubhouse. I am your host, Dragonborn, and today I'm going to teach you about atomic bombs. These form the basis, are some of the things which form the basis of our world, along with the four fundamental forces. The camera I'm using to film this, the body I'm in, the chair I'm sitting on, the board, the camera person, all of these are held together, are collections of atoms held together by atomic bonds. So, I will teach you about the three main types of atomic bonds, some examples, and some misconceptions. So, here we go. First, something about want to mention something about about electrons. With these electron clouds, I couldn't really draw a good representation. But there are but one of the bases of atomic bonds are electron shells. So within these electron probability clouds, there are different energy levels in different shells. And if an atom has a shell that is half full, it could go when it bonds with another atom, it can either take electrons or give out electrons. If it has less than half of its electron shell filled, one of the electron shells filled, then it will give electrons off. Like, for example, metals like magnesium, lithium, and sodium. The reason those are explosive is because they give off electrons, because their electron shells are almost completely empty. On the other hand, things like chlorine, which chlorine gas was used as a chemical weapon in World War I. The reason it's dangerous is because its electron shell is almost full. It's over half full, so it will take electrons from other atoms. So, with that baseline, let's get into the bonds. First up is the covalent bond. In this, the electrons are shared evenly between each atom. This is the type of bond you would get between pieces of metal. Like, all the pieces of metal in this are the same type of would be bonded together via covalent bonds. Since not all of them have the same electronegativity, which is basically how much the atom attracts electrons. Some different categories include polar and non-polar bonds. Covalent bonds are non-polar bonds, and oil is another good example of a non-polar substance. Another subsection of covalent bonds are polar bonds. Water is a good example. The oxygen atom has a lot more electronegative than the hydrogen. So the electrons spend a lot more time around the oxygen than the hydrogen, leading to the molecule resulting from it being polarized, thus polar. Now, a third type. Well, before I move on, polar bonds and non-polar bonds do not mix. This is why you can't mix oil and water. But there is a way around this. Some molecules have a polar end and a non-polar end. Soap is a good example of this, and these are called surfactants. The the reason you need soap for you need soap to clean dishes is because most of the dirt is non-polar, which water being polar can't bond to and wash away. So you need a surfactant. So one end bonds to the non-polar end, and the other end bonds to a polar molecule. So the momentum from the water molecules can move the dirt off. The final type is an ionic bond. This is the type. This is what leads to table salt. Combination of chlorine, which I've already mentioned, which takes electrons and is a deadly gas, and sodium, an explosive metal. Combine the two together, and you get an ionic bond. Now, ions are an ion is an atom with an imbalanced charge. A positive ion is called a cation. So just think of a cat meowing or something every time you hear talk about a positive ion. A negative ion is called an anion. So how this happens is, I mentioned with sodium and chlorine, these aren't the elements; these are just used for examples. So what happens is, when one atom comes across another, instead of sharing electrons equally or otherwise, as in the previous two types, this time one atom's so much more electronegative than the other, then it basically rips the electron from the other atom and adds it to and takes it for itself. This is what causes the imbalance of charge. Then one is positive, one is negative, so they're attracted to each other, and that's how an ionic bond forms. Now, some misconceptions. 1. Atomic bonds do not store energy. It takes energy to break a bond, and energy is released when a bond forms. Nature tends towards the lowest energy state. So, if you ever hear someone talking about atomic bonds, or hear something mention how it's storing energy in the bonds, that's not true. Second, you may hear people talking about how they don't like chemicals in their food. Well, any two atoms that are bonded together, if they aren't a pure element, like if it isn't like something like this where it's a pure metal or pure element, it is a chemical. So two elements like table salt is a chemical. Everything around you that isn't something made up of a pure element like gold bars or silver is a chemical. So you cannot. So the correct thing to say would be harmful chemicals. And one last thing before I summarize and end the episode. There are when it comes to molecules, I couldn't draw it here since I ran out of space. But there are some molecules called enantiomers, ENOTI, omers, and these are molecules which are basically the same chemical composition, the same types of bonds, but just mirrors of each other. One example, methamphetamine. If I'm correct, left-handed. These are designated as handedness. left-hand methamphetamine is a nasal spray which helps open up your nasal pathways to help you breathe. I think it's right-handed methamphetamine is the street drug known as meth. The main difference is that these can only activate certain receptors, like how a right hand can only fit into a right-handed glove, and a left hand can only fit into a left-handed glove. These can only activate their receptors. So it is literally impossible to get high off of nasal spray, and you cannot use meth to clear your nose. So, yeah. And that will sum up this episode about atomic bombs and some misconceptions about them and molecules. So, I hope you enjoyed this episode. If you like the episode, please like the video and subscribe to the channel. If you have any constructive criticism to give, please let me know in the comments below. Have a good whatever time of the day it is, and bye.